Okay, good morning, everyone. So as Carsten said, my name is Bojan. So I work in computing and software support at ECMWF team. And basically, this is recycled material from previous courses we had, and which was mostly done by Carsten and Dominique. And this year, I will do all the presentations and practicals. So in the first session, there will be 2 sessions. So the first session is to cover basic concepts and basic things about Mars, and then we will have practicals with basic usage of Mars, just for you that you can exercise how to retrieve the data. And then the second part, we will go to the more advanced Mars usage, especially highlighting efficiency. And then we will also have practicals with let's say, more sophisticated Mars usage. So as you found yesterday, Paul presented our data handling system, which consists of 2 parts, ECFS and Mars. And Mars, as Paul said, is much bigger. So Mars covers 75% of our archive data. And the purpose of Mars is for us, for ECMWF, to be able to store all the data we produce. But not only that, it's the second goal also is to make this data available to the member state users, to internal users, and also to the private customers. So as I said, so we will first touch Mars architecture a bit, because it's always good to know how Mars works inside, and that can help you to better understand the system and to use it more efficiently. The second part will cover like most popular data set, meteorological content of the data we have stored in Mars. Then we will go to Mars language, and then I will show you some example how to retrieve the data, and then we go to the practical sessions. So as I said, Mars is not a planet. It stands for Meteorological Archival and Retrieval System. Basically, it's the biggest meteorological archive in the world. Mars is usage of Mars is, well, in Mars, you can only store a few types of data. That's grip data for the NWP, buffer data for the observations, and also ODB, which is ECMWF format for the observations, which we use in data simulation. So it's a large amount of data. And Mars is operational service. So at the end of the year, Mars is available more than 99% of the time. So we consider it as operational service. And it's just one way to get ECMWF operational data alongside with the dissemination. But as I said, Mars also contains all the historical data. So the architecture of the Mars, it's basically client-server architecture. We have Mars server. Well, we have several Mars servers, and we have clients installed on the ATOS HPC, which you will use during this practical. So when you log into ECS or HPC, you have Mars client installed there, and you call it with Mars command. Mars client will send your request to the Mars server, and then server will look for the data. There are a few places you will see later where data can be. So the server will find the data and send it back to the client. So first, the data storage is field database. This is basically the HPC file system, raster file system. So the most recent forecasts, the latest 10 days for the HRES are kept in the FDB. Also for the ensemble operational forecast is also kept in the FDB, and this data can be retrieved really quickly because it's just copying the files from the same file system to your local directory when you execute the request. Then there is a DHS data handling system, and on DHS we also have some disks, classical disks, and more popular data and more recent data is cached on the disk. However, most of the data is distributed, is saved on tapes. And basically, when you query for the data which is on tape, that request will take a longer time than any other case. So I said we have 6 Mars servers. So basically we have one server which is holding operational data. Another server is in charge for the research data. Also, we have server for the member state data in Mars and so on. For the FDBs, which are on the disk on the HPC, we have 2 of them. One is FDB and FDB-BC, which holds only data produced by boundary condition programs. So these are forecasts issued at 6th and 18 UTC. And basically only only users from participating member state in the boundary condition program can access this valid data. So Paul also showed you some figures yesterday, but just as a refresher, in Mars we have 450 petabytes of data currently, and we archive 400 terabytes a day. We have 8,000 users with access to Mars, which can access to Mars, but around 1,000 users are active daily. So every day you will see 1,000 users retrieving the data. And in total, we have around 1.5 million requests per day. This is average, but on some days we have much more. So for example, average retrieval is 350 terabyte this year. And 6 years ago, this was like only 100 terabytes. So now it's we have more than 3 times retrieval activity. And also we have seen some days when with a peak of more than 500 terabyte of data retrieved during the 24 hours. What is important to say that only 2.6% of the data volume is stored on the disks on the HPC and DHS, and more than 90% of the data is on tapes. So when you are querying for historical data, it is most likely that the data will be on the tape. We keep operational forecast, which is produced since 1985, and also analysis and observations, which started in with ERA 20C. So just to get a picture, what is about the data size we have in Mars. So for example, if you have 100 megabits per second read-write speed to the disk, it would take you more than 4 months to copy 1 petabyte of data. And daily we deliver user retrieve 30% of petabytes, and we archive almost half of the petabytes. So as I said, this is a picture. More than 97% of the data is stored on tapes. So on the right-hand side image, you have a look in one of these tape libraries, and you see the robot hand, which is fetching the tape and then put the tape to the driver so the data can be copied. And on the left-hand side, you see these the tape libraries from outside. This is in the new data center in Bologna. So now to the content of the archive. So the most popular terminology we use. So the most popular one of the most popular product is medium range forecast, which is high resolution forecast, deterministic and ensemble, deterministic up to 10 days, and then ensemble up to 15 days. Then extended range forecast is also quite popular. It goes 46 days in advance. And then we also have seasonal forecast, long range, which goes more than 1 year in advance. And this is all stored in Mars. Also, hindcast is quite a popular product. So reforecast, which are done to estimate the model climate. And yeah, for all these products are made using IFS integrated forecasting system. And then I included this, you will get this presentation, so I included this link so that you can check documentation about the IFS and the data sets we have in Mars. Okay, as I said, one of the most popular data sets aside from operational forecast is reanalysis. Basically, it's not comparable. You cannot compare how popularity between these two, because operational forecast is available only to member state users and some private customers who are paying for it. Reanalysis, because it's funded by Copernicus, it's open to everyone, and the gate to get the Copernicus data, ERA 5 data, which is the recent reanalysis, is CDS. and you can see the web page of CDS Climate Data Store. So you can in the web browser you can select the data and then you can retrieve it, but you can also install Python CDS client and then you can from your computer get the data programmatically. Also on the left-hand side, you can see a snapshot of the Mars catalog, which holds information of all the reanalysis data at ECMWF. If you have Mars access, which you do, you can, and you have workflow retrieving the data from the HPC, from the ATOS HPC, you can always also get the RFI data, even though the official way is to go through CDS. Yeah. We also have some public data sets which we are decommissioning. So now we have only 2 public data sets which can be accessed from outside using the Web API Python client or the public data set web interface. And basically this is something we will decommission by the end of this year. And then these 2 data sets, TG and S2S, we will provide in a different ways. So probably they will go to CDS, or another alternative way will be fine for this data. Okay, so as I said, unlike in ECFS where you can store everything, in Mars we can only store GRIB data, and you will find now we have 2 versions. So some fields are in GRIB 1, other fields are in GRIB 2, and also ECMWF local extensions. The data which is archived for upper air from IFS, this is mostly in spherical harmonic, and also for the surface data, Gaussian grid, and for the wave products, latitude and longitude and grid. And we also have buffer for the observations, which we collect to do our own data simulation, and then we store the analysis, and we also store the raw observations which are used. So now to the Mars language, it's a simple syntax. So it always starts with a verb, and verb marks the action. So verb can be retrieve, download the data, list content of the Mars archive, which will only query the database. So it will not retrieve any data. And then you can also use read. So Mars can read from your file on a disk. So you can read from file you specify. And then it goes with the keywords as a variable, and each keyword has its own value. And what is the most, well, there are so many keywords, so we have a Confluence page with a list of all of them, and then you can click on any one you want, and then you see the description. It's very detailed and nice, so you will get this as part of the presentation. So what is important, spaces in Mars request are ignored, or tabs, so you can use any. You can use star, you can use hash for comment, which is like what you would regularly use in Bash, in Fortran or C. All comments are accepted. Directives are not case sensitive, so you don't need to worry about a capital letter or small letters. If you specify a list of fields, you use backslash to separate, and you will see more in the example of the request. So basically, this is an example of a Mars request. It always starts with the action. Here it's retrieve, so we want to download the data, and then identification part of the request, which defines so class OD, operational data, stream is OPER, which is deterministic forecast, and experiment version is 1 in this case, which means the operational version. And then you go to the date time related variables. So you define a date. You can choose specific date, or you can use relative date from today. So in this request, the forecast based will be 3 days before today, -3. And the time, it can be 0 and 12 in this case. And then we go to the data related query. So we request analysis. So this is type analysis. If you want forecast, then type is forecast. Level type, in this case, model levels, but aside from model levels, surface level is popular, and also pressure levels. So here we want all 137 levels. So we say 1 to 137. We don't need to specify to list all of them. And parameter 130, which is temperature. So here you can also use sometimes short names, temperature, and it will work in some requests, but we strongly recommend to use param ID of the grid because only that is unique, and only with that you are sure that you will get parameter you wanted to get. And then we go to some post-processing option. In this case, we want to get latitude, longitude grid, 2.5 degrees. And at the end, we specify target file. So this data will be saved in the file called analysis. And that's it. So as I said, class specify its ECMWF classification of the data set. So most popular OD, operational, RD, research, EA, it's for reanalysis. And then we go to the stream. So OPER is high-res, ENFO is ensemble, wave for the wave forecast, and so on. And then experiment version, you will always find one, which means operational version, but there are many others because we run models in research mode before they get to the operational service, so you can get that data as well. And then for the date time command, it marks the base time or the observations time if you are extracting observations. Date is a base date when model started, and as I said previously, you can use relative date, or you can specify year, month, and then a day. And then we go to the step which is valid only for forecast. So basically you can give a list of forecasting steps you need, so you don't need to retrieve all the steps. Type, as I already said, we have most popular in the operational forecast analysis and forecast. And then level type, most popular are pressure levels. We have from operational forecast something like 30 levels. Model levels, we archive all the model levels from the high-res. From ensemble, we cannot do it because it's it would be too large for Mars. Then surface data, most of the parameters we archive are surface parameter. And then we also have from some data set potential vorticity and potential temperature levels. Basically, level list is also important, so you specify all the levels. If you retrieve the surface data, then you don't need to specify level list because obviously there is only one surface level. And then list of parameter, as I said, for temperature, it's 130 parameter ID, and you can always use Mars catalog to select parameters you need, and then Mars catalog will show you the parameters ID you need to pass to the Mars request. So you don't need to know these things. You can just use Mars catalog and it will create list of parameters for you. And also number is popular. It's only valid for the ensemble forecast, so it marks the number of ensemble members, so you can get all the ensemble members, 50 of them, but you can get only few, so you can specify a list you want. And yeah, for the observations, we have raw observations, we have feedback, analysis input, analysis feedback, and we also store some satellite images we use in the data simulation. Ops type, surface observations, air observations, WMO observation station you can specify, and then you can get that specific station you want. You can select whether to keep the duplicated observations or to keep or to remove them. You can also use WMO block number for the observations, and also like with the forecast, you can select time and range. Range is time range within specified time range, and with that time range you get all the observations we have stored in it. And then in the end, as you saw, we specify target file. So because you will do your practicals here on the HPC, you will want to store all of your grid files on Scratch, because Scratch is a large size file system. And then you need to use quotes when you with the slash when you specify the full path to your target file. Post-processing option. So as I said, one of the most popular post-processing option is to have destination grid in latitude, longitude. So the finest grid from the operational forecast is 0.1, but you can also select any resolution you want.
and is specified with the grid keyword in Mars. We also have options to retrieve Gaussian, full Gaussian grid, and then that this is coded as F, and then the number after F is resolution. There is well, with Gaussian grid, we have the same number of longitude points at each latitude circle. With the reduced Gaussian grid, however, the distributions of the data points is more uniform, so it follows the CFL criteria, and this is what we use basically in the model. So basically here the distance between points is constant, so if when you're going from the equator to the pole, you get more and more, less and less, sorry, data points. And octahedral is very similar to reduced Gaussian grid. It's just a small difference in formula, how you calculate the number of longitudinal points. So yeah, it's a very small difference. And octahedral grid is now used in the operational IFS. Also for post-processing, you don't need to extract the global data. You can most people are interested only in subdomains, and you can specify your subdomain with the area. So you can here you see as an example, so 75, 25, this is northwest, southeast borders, latitude, longitude, and then you get grid, which is plotted here for Europe. And then you can also specify some interpolation options. There are a few options what to do with the native grid before the interpolation starts. And you can also select the accuracy, which is number of bits per data value in resulting grid file. Default is 16, so most people go with 16, but yeah, you can add more bits per value or less if you wish. So these are some of the more sophisticated Mars keywords. So basically, if you have some research data sets which is not complete, so one day you have this number of product and another day you have another number of fields. So if you know that, you can specify expected number of fields, because this is not consistent, and so to prevent Mars of throwing errors. But in general, you don't need to use this variable for the official operational products. You can select the database. So basically, you have seen we have the data stored in the FDB on disk on DHS. And so there is an option to specify that, to say, yeah, look for my data at the FDB only. But also this is something as a regular user you don't need to use, because Mars knows this. Mars will always first check the FDB where the access to the data is fastest. If data is not there, it will go to the DHS disk and then to the tape system. Yeah, so what Mars does when you submit request, it calculates number of fields you requested. So basically, if you have 31 days forecast for entire month, that's 31 fields, and then you have three parameters. It's in total 93 parameters, and Mars will check when your request is done whether you have all 93 parameters in your target file. If not, you will get the error message. And then you will need to check for some variables. You can use values all, like for the level list, you just say all, and then you will get all the level list. But it's always much better to use to specify the exact list, because there are resolution changes. And then if data is missing and you specify all, and one of the level is missing or data is damaged and you don't get it, you will not know about that. So it's always recommended to use a list of levels you want. And also you can use value of, which means if you have, for example, two requests in the same script, and the first part is getting the model level data, and then you have list of levels, and then second part is getting the surface data, you can always use level list of to switch off the variable defined in the request above. So you can switch it off. This is one of the example how to retrieve the operational analysis. So the class OD, operational version, date. These are like 10 days of analysis. All times when analysis is made, 4 times per day, and then we select the surface field and one parameter, and then we store it in our target file.
And how we run it, so basically Mars client can accept directives from input stream, so you can type this. It's easier, I think, to store Mars request in a file, like in the bottom case, the file name is my request, so you can write your request to a text file, and then you can use Mars command to execute your request, like in the bottom line. And then when you retrieve the data, you always need to think about efficiency, of course, and then you need to avoid using of default values. So you want to give all the keywords, because then you know what you are going to get. If you specify, for example, in analysis, if you don't specify class or something like that, Mars has its default, so it will try to guess what you want. But you are always safer if you specify everything, and you can always use Mars catalog to create a full request for you with all important keywords. So syntax is checked when you submit Mars request, and you will always have you don't need to run it in debug mode. In regular mode, when you run Mars request, there will be a lot of useful information in the output. So all important information is written. It follows the info flag, and then you will see warning messages which are issued if something is if there was some unexpected action, and then the error message if you have any errors, if you ask for some data which is not available or something happens with the connection, then you will see the error message, and then fatal message which terminates the execution of the Mars request. So yeah, as I said, the entry point when you want to get something for Mars is Mars catalog, which is a web interface. I will show you. There is a short video how to browse the Mars catalog. So you select your data set, and then in Mars catalog you will see several options. So it can create a Mars request for you. You can download the data directly from the web browser. You can estimate the size, and you can check availability of the data you selected. Yeah, so this is how it looks when you open the start page. And now maybe I can play this video. So now I'm in the home page of ECMWF. So going to the forecast and then data sets, and then I will see operational archive, and then I will select Mars catalog. So open operational archive with Mars catalog. And then I can set the atmospheric model. I can set the operational version, and then forecast, and then year, month. This is level type, so I will just go for surface, and then you can pick any date. You can pick a forecast start time, and then you can make your selection. So here you select the forecast steps you want to retrieve. And then on the right side, you select parameters. And I will take only 3 parameters. And you can see the availability of the data. You can click on that and it runs. So you can see there are no any errors. So the data is available. And then you can go back to the selection page. And then you can estimate you can see actually the Mars request. You can just copy it from here and paste it to your script and then run it on the HPC. You can also get the MetView macro. If you're familiar with MetView, you can get the MetView macro to download the data from MetView, which works only for MetView installed at ECMWF. And then you can check the data size of your selection. And then you also have option to retrieve the data in GRIB or NetCDF. But in our practicals, we will do this from Mars client on the HPC. So also on the same page, you have an option to check Mars activity. So you can check activity of your requests. You can check activities of all Mars requests and Web API requests. So this is one way to see what is happening with the request you submitted. You can see whether they are active or queued. And there are some tools when you retrieve the data, and then Paul will do the EC codes after this presentation in the afternoon session. But basically, we mostly use EC codes to check the data to make sure that all the files are there. But you can also use MetView or CDO. CDO is also installed on the HPC. So when you submit request, there is first syntax check, and then maybe we can see request. So the first we have syntax check, and then your request is printed. This is all in the output of your request. And then you see these messages. So first Mars will query FDBs, and then it will query may not high. If the data is not in the FDB, then it will start transferring the data. So you will see number of bytes which are transferred. So you will see if you selected any post-processing options, it will be here with the transferring data. And then in the end, you have reporting results. So no errors, memory usage, and then data transfer. So basically you have everything here. It's always good to check it, even if you get the target file. It's always good idea to check the Mars output, because then you can see if something was missing or any issues, or if the download was complete or partially complete only. Talking about efficiency, usually there is a rule to store 1 month of analysis on one tape file. So if you are downloading analysis for longer period, you will always submit one request for entire month and then another request for another month. For forecast is different. For forecast is in one tape file you have only one forecast, and you have all the time steps for selected level type. For ensemble is similar, like for the forecast, you have one tape file is for ensemble members, and then another one is for control member, and then all the time steps for selected level type are stored in the same tape file. So for example, if you are retrieving 50 days of forecast, it's reasonable to submit 50 requests, one request for each day. Yeah, so to check your efficiency before submitting, it's always good to go to the Mars catalog, because you have seen in the Mars catalog page, you always have listed all the data which is saved in one tape file. So you need to get all the data from there in one go. It's always good to estimate the download size. The reasonable size is 100,000 fields in number of fields, and the data size, it depends really, but if you are getting ensemble data, then even 100 gigabytes is reasonable enough. You need to check always compute resources, so it's always best, and you will do this in practicals, to submit large Mars requests as a batch jobs. You learned batch jobs yesterday, and then you submit small fractional job, and you can give like a long wall time 1 day or even longer for a large request. You also need to be careful to store the data on Scratch, and also to check the quota, the amount of data, amount of space available you have on Scratch before retrieving large data from Mars. And what you should avoid is to constantly access the same tape. As I said, you need to get all the data from one tape in one go, because then the longest part of your request is waiting for the tape data to be copied. And then if you do this several times for the same tape, it's not efficient at all. So there are several categories in access to Mars. So basically all of you here, you have basic access to Mars, which means you can retrieve historical data. There is also something we call access to the valid data in Mars. So this is data with verification time in future or in the last 24 hours. So most of you cannot get this data from Mars. This is something which can be given to you by your computing representative. And in our practical, we will not include this. Basically, we'll do only historical data, and anyone has access to historical data. This is separated because for the valid data anyway, we prefer dissemination for operational data transfer rather than Mars. And then we don't have large number of users and member state with access to valid data. Also, there are some other restrictions. For example, member state, they can archive their own data. For example, Cosmolabs, they archive in Mars, and then only people from Cosmolabs community, from Cosmo community or now Icon community can download this data. So this will not be accessible to everyone, and you will see it in Mars catalog. Another way, alternative way to download the data from Mars is to use Web API. Basically, Web API, you can trigger download from the web browser, but you can install a Python client, and then from Python client you can submit your Mars request from your local computer. You don't need to log in, and this is mainly envisaged for users with access to Mars, but without access to our computing system. For example, private users who are buying the data, they have this web API. You can also use it, but there are some additional limitations comparing to what you can do from Mars client on the Atos HPC. So for example, with web API, it doesn't have EC codes, so you don't have additional functionalities like compute, read file from target, and write. You cannot write in single request to multi-target, which you can do on the Mars client. There are also limitations. Currently, only one active request is allowed per user on the web API side. Of course, with the Mars client, you can do more. This is restriction on top of normal Mars restrictions. And there is restriction for the target size, which cannot exceed 675 gigabytes per request, and 600,000 field, which is a lot, but maybe if you are getting all the surface data from all the ensemble members, that is usually more than 600 fields, so you would need to split this in half. If you are doing over web API, and from Mars client on the Atos, you can do it at once. So yeah, this is structure. So web API you can use for regular Mars access, or to get only publicly available data sets. For public data sets, you still need to register. You still need to create a key, because we do some statistics, how many retrievals and users, so we can track the usage, but basically anyone can do it. For Mars access is different. You need to create your key, and then if you have Mars access, you can use it to get the data from Mars. And this is one example of the Python web API example. We will not do this in practical, but you will get these slides with the link to the documentation. So if you want to use it, you can. Yeah. It's well documented. And these are linked to some additional resources, and we will not go through this. So now I suggest that we go to the Gather Town and do the practical session.